All right. Welcome, everyone. Welcome to my channel, Maths Made Easy with Terry in 10 minutes. Okay. So we're going to start with, we're doing binomial theorem today. Okay. But I'm going to start with binomial expansion. I'm trying to build up the understanding and lay the basics before we go straight into things like the binomial triangle, Pascal triangle, binomial expansion for both positive and negative. Okay. I'm going to do this. This video is more of a review, just a quick review to remind us of some particular terms and how to do things. Then after that, I'm going to dive straight into showing you how to work with each of them. Okay, so the first thing is that I want to first review how to expand brackets. So just to remind us, for instance, if we have x plus 1 squared, how will you expand it? If you remember, it follows a particular theorem of expansion of bracket. If you have a plus b and c plus d, for instance, the first thing you do, you multiply a and c to give you ac. Then you multiply a and d to give you what? AD. The next one, you multiply b and c to give you what? BC. All right. Then you multiply b and d to give you BD. This is how you expand brackets, okay, from algebra. All right. But the same thing applies to when you have x plus 1. So that means you can write it as x plus 1, x plus 1. Does that make sense? And this would now follow the same principle. X times x, okay? The same way you expand the bracket will give you x squared. X times 1 will give you what? X. All right. 1 times x will give you what? X. And 1 times 1 will give you 1. So you add them together. So it's going to give you x squared plus 2x plus 1. All right. And that will be that for that. All right. The same principle if you had x plus 1 squared, or sorry, cubed, for instance. Now, it's still the same thing. You can write it as x plus 1 squared multiplied by x plus 1. Are you seeing? We've already solved this question already. X plus 1 squared, and we found out it was x squared plus 2x plus 1, right? Now we now have x plus 1. So you see, it's still the same thing, but you have to then expand one particular bracket first, then you now go to the other one. Sorry, expand a particular pair of brackets first, then you now add the other one, and you keep going. So you now expand this. It's going to be x squared times x will give you x cubed. X squared times 1 will give you what? X. 2x times x will give you 2x squared. 2x times 1 will give you what? 2x. 1 times x will give you what? X. And 1 times 1 will give you what? 1. You collect like terms, so it's going to be x cubed. We have 2x here plus 2x. We have x. So this is x plus 2x plus x will give you 4x. Can you see? Then you now have plus 1. Okay? Then that is the answer for that. So this is 2x squared, sorry. Then plus 1, and that will be the answer for that. Now, that's the answer we've gotten. But the thing that you have to keep in mind is we've done this, okay? Just to remind us, so it's x squared times x will give you x cubed. X squared times 1 will give you x. 2x times x will give you 2x squared. 2x times 1 will give you 2x. 1 times x will give you x. 1 times 1 will give you 1. Then you collect like terms, and that's how you get the answer. But the other way is to expand the bracket, because if, for instance, I'm giving you x plus 1 raised to power 20, for instance, will you have to then be doing this up to 20 times or stuff? It's going to be very, 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 very long, okay? And because of that, we have to use other methods to what? Expand brackets or try to solve this question. Now, the first thing that you have to keep in mind is we're going to talk about two methods in this series. I'm going to talk about using Pascal's triangle, okay, because it's very important. Using Pascal's triangle, okay? And you only use Pascal's triangle when you have positive integers only, okay? When you have positive integers only, that's only when you use Pascal triangle. Or the second method you could use, you could decide to use the binomial expansion or using binomial theorem. Okay. So using the binomial expansion. So you can call it the binomial expansion theorem. Now, the interesting thing about this is that you can both use it for either positive, or you can also use it for what? Negative. Okay. So both positive powers. All right. So then put the powers there. So it'll be easy for you that are taking notes. And negative powers. So you can either use it for positive powers or you can use it for negative powers. And when we talk about binomial expansion, basically we're talking about is the sum or differences of two terms, all right? And also just to remind us, I've talked about this before in my previous videos. When we talk about the terms, we're talking about the numbers. Like for instance, in this example we solve here, this is the first term, okay? This is the second term, and this is the what? Third term. So that means there are three terms here. In this example, we have four terms. So we have, this is the first term, okay? This one here is the second term. So this is the first term, okay? This is the second term. This is the third term. And this is the what? The fourth term. All right. All right. So that is it. So what I'm going to do is that because of time, I'm just trying to lay the foundation for this video. So basically what I've talked about is that the same way you can open a bracket is the same way you can open a bracket, but this time we're not going to use this method because it could be cumbersome when you have a big set of numbers or a big set of positive powers or negative powers integers. So what do? We then want to use two methods here, okay? We can either use the Pascal triangle or we can use the binomial expansion method. But the Pascal's triangle is only for positive integers only, while the general form of the binomial expansion is both for positive powers and negative powers, all right? So what I'm going to do is that I'm going to start with the Pascal's triangles in the next video. I'm going to talk about it. Then after the Pascal's triangle, then I'll go straight to the binomial expansion for positive, and I'll now go to binomial expansion for negative, okay? All right, so I'll see you in the next video. Please, if you have any question, like I said, please put it in the chat box. And don't forget to like and subscribe or share to other people that you think would need the video as well. All right, thank you very much. So see you soon.